In this video, we're going to show you how to get started with your first project using the Rapid IoT Kit from NXP and the development tools using the Rapid IoT Studio. First, you're going to want to log into your NXP account at rapid-iot-studio.nxp.com and then navigate to the Studio area using the icon in the upper left of your browser. Once there, you will be presented with the Studio's Project Management area. Here, you can load projects you have saved, import and export projects, and also load various examples that are available on the website. Now, let's create a new project by clicking the New Project button, and then giving our new project a name. We'll call this Getting Started. This will bring us into the project editor. Before we start editing our project, let's familiarize ourselves with the various parts of the Studio editor. The projects are divided into 3 planes. Each plane is represented by its own tab. First, there's the embedded plane, which controls what the embedded device will be doing. The next is the application plane, which will control what the mobile application is doing. And finally, there's the cloud plane, which will control what the cloud will be doing for this project. For this tutorial, we are only going to be working in the embedded plane. The embedded plane editor is divided into different sections. Here, we have the designer area, which is where we will be wiring up the interactions between elements. And on the right, we have the element toolbox. An element is a visual representation of a functional part of your project. For example, there are elements that represent a GPIO element, a UART element, embedded displays, and sensors as well. In the Studio, you're working with elements. And to add an element to our designer area, we simply click on the element type we want to add from the toolbox. Let's start by adding an interval element, which will enable us to use the embedded interval timers. We will also add the ENS210 temperature and humidity sensor element. Every element is comprised of properties, triggers, and abilities. You can see the various properties that are available for you to set for this interval element. Properties allow you to configure the element. Here we have triggers. Triggers occur when a certain condition occurs in the element. For example, the interval element has a trigger for when the trigger ability is used called triggered, and also a trigger for when the interval timer goes off called interval. We can now create a connection between the interval element and the sensor by dragging the connector from one to the other. What this will do is add an event to the interval trigger. Each event describes what action should be taken when a trigger is executed. So in this example, the interval trigger has one event in which we have the sensor element execute its read temperature ability. Now when that ability executes, the sensor element will execute its temperature read trigger events, which we can then use to update the embedded display. To do this, we are going to have to add the icon label display element to our project. This element allows us to display a graphic on the embedded display and a label under that icon. We will set the page title to temperature, and also set the icon to the temperature humidity icon that is predefined for us. And now, to complete our project, we just need to connect the sensor element to the icon label, and we're done. At this point, we're ready to build our project, and we do that by clicking on the build icon, represented by the hammer, in the upper right corner. This will convert your elements and the various properties into embedded source code, which our servers will compile for you. At this point, we need to get our kit ready for programming. To do this, we simply press the top right and lower left buttons on the Rapid IoT Prototyping Kit and wait until the screen turns off and the LED starts flashing green. Once you've done this, the kit will show up as a USB mass storage device. Back in the Studio IDE, now all we have to do is click the Download Firmware button and save the binary firmware file right into the Rapid IoT Prototyping Kit. The kit will go through various stages of programming indicated by the LED, and then start running our project on the device. As you can see, we now have our labeled icon displaying with the current temperature reading on the UI kit's embedded display. We hope that this tutorial helps you begin your journey into unlocking all of the Rapid IoT Prototyping Kit's possibilities. Thank you.